Welcome to Module 203D on efficient gas-fired forced air heating systems. In the third objective, we're going to be looking at all the other components that are related to the furnace, but not necessarily part of the furnace. When we refer to standalone devices, we are talking about devices that require a signal from the furnace, such as the HRV units, air conditioners, humidifiers, and air filtration systems. So all these different devices will be interlocked with the furnace operation. Filtration systems are a necessary part of the furnace, and their job is to remove the particulates from the air. They're normally installed in the return air duct right before the blower, but there's different types of filters that can do different jobs. Cartridge filters come in a variety of options. We have a basic filter, which is a standard fiberglass, which only removes the particles that could damage the furnace components. Above that, we have mid-efficiency filters that can remove mold spores and particles between 3 and 10 microns in size. High-efficiency filters will remove particulates as small as 1 micron, and microbiocide treated filters will inhibit organism growth. We also have electrostatic filters, which use air movement to build a static charge and can remove microscopic particles, and there's no power required for these. Higher filtration also means higher air restriction, so we need to be aware that the finer our filter is, the more stress we're going to be putting on our system as well. We also must make sure that our filters are changed regularly to prevent any damage to the furnace and to help it work at optimal efficiency. Any excessive dust on the filter may spill through and damage the parts within the furnace. An alternative to cartridge type filters is the electronic air filters, and they use electrostatic principles. They charge the dust particles with a high voltage, and then the dust is attracted to the oppositely charged plates. They do need an external power supply, and they need to be washed off in order to clean them. They also must be connected to the circuit board so they are only on when the fan is running. Humidity is the amount of moisture air can hold at any given temperature, and as we discussed in Module 203A, humidity in the air is a large part of our human comfort level. Less than 20% it feels cold because we have lots of skin evaporation. However, more than 80% feels muggy because it prevents any evaporation from our body. About 40% at around 22 degrees feels right to most people. The job of a humidifier is to add moisture to the air, and they are mounted on the hot air plenum above the furnace unit. There are a number of different styles of humidifiers that can be used, each with their own advantages and disadvantages. The standing water humidifier is the most basic type that we can get. It has a float switch on the inside which stops any water from coming into it when the water inside the unit gets low. And then it has a sponge that wicks water out of a tray. The air movement across the sponge evaporates the water. However, the sponges can become crusty and the water can become stagnant. Another common type is called the rotating drum humidifier. The rotating drum humidifier will require power for the motor. It has a foam pad that rotates through a water bath. Once again, the sponges in these can become crusty and the water here can also stagnate. Similar to the drum style, we also have a rotating disc humidifier. And instead of a sponge, it uses plastic discs. In this case, we don't get any water stagnation or crust buildup. The last style we'll look at is called the flow-through humidifier. It has water flowing in the top of the unit, which drains a steady, light stream of water down a metal or plastic screen. The problem with the flow-through humidifier is it can become wasteful because the water that comes out the bottom is simply drained away. Regardless of the type of humidifier that we have, we need a humidistat to control it. The job of a humidistat is to measure the moisture level inside the air, and it can either be a standalone unit or be part of a thermostat. If it is a standalone unit, it's usually located with the thermostat inside a central area, and it is connected to the circuit board using either the heating accessory and the common terminal, or if it has a dedicated HUM terminal, which stands for humidistat. Anytime that the heat is on, the humidifier is also going to be on as well. Our next standalone component is called the air exchange systems. The average home needs about 0.35 air changes per hour, which means over a 3-hour period, we would be changing all the air inside the house. This is going to prevent combustion gases from being drawn back into the house through the flue, and we use either an air exhaust fan or an HRV unit. If a building has a dedicated air exchange systems, The fan is located in one location with ducts going into each area for air circulation. Turning on the common exhaust fan will cycle air in all the bathrooms in all the locations at the exact same time, and these are typically interlocked with the furnace and the HRV unit. The HRV unit is needed to heat any air brought into the home. It uses the heat inside the exhausted air and transfers it to the incoming air from outside. That way, we have preheated the air before it enters our system. When the air system needs to be interlocked with the furnace, it is common to use an external relay. The relay will close the contact between the R and G terminals on the furnace control board, starting up the furnace fan. That way, we can move the air around the house as we bring the fresh air in. You've reached the end of 203D. Please return to Blackboard and complete your knowledge check, and make sure you do the reviews on modules 203A, B, C, and D, and the practice test for test S31.